Hey guys, so I'm gonna give this .chem a whirl. First skill set is to simplify radicals. So simplifying radicals, what I do is I make a factor tree, as you can see the steps here. And so I make a factor tree. 75 is 5 times 15, and 15 is 3 times 5. And a factor tree is done. And basically, since it's just a square root, I can just look for pairs of numbers, basically. So like a pair of 5s here at the end means that I can actually remove a 5 from under the radical. And then this 3, it doesn't have a pair, right? There's only one 3. It has to go back under the radical. So remember, you're taking square roots out. So since 5 times 5 is 25, when you take the square root of that, you get 5 outside. On this one, and there's different ways to do it. So like you could do it differently. You could be like, well, you know what? This is 5 times 100, and the square root of 100 is 10. Like if you know the square root already. So since we know the square root of 100, or if you do recognize that, you could just take the square root out of that, and so the 100's gone, and there is still a 5 in there. So there's that. The square root of 17, that's a prime number, so right, it's prime, we can't do anything with that. The square root of 12, so again, I'll show one method. You could just break it down to a couple factors, and if you have any square factors, then you can take the square roots of those factors. So like, for example, 12 is 3 times 4, take the square root of 4 out, that's 2. 3 doesn't have a square root, so there's that method. Or again, you can do the factor tree. So this next problem, the square root of 60, I'm just going to use the factor tree method. 6 times 10 is 60, 2 times 3 is 6, 2 times 5 is 10. These are all prime numbers now. Remember, I'm looking for pairs of numbers, so I can take out those square roots. So there's a pair of 2's, so a 2 can come out. The 3 and the 5 don't have a pair of numbers, aka there's no square factors, no square roots to take. When two numbers go back into the radical, if you did this method where you took them out, they get multiplied. So there's that. This one here, same thing. I can break this down to, I can just make it like 9 times 11. This may be an easier way to do it if it makes sense to you, where if you break it down to the square factors, you can just take the square roots of those factors. Like the square root of 9 is 3. 3 comes out, the 2 that's already out there, you're going to multiply with that 3. 11 stays in the radical, 3 times 2. 6 square roots of 11. Multiplying, can you still see? Yes. So multiplying radicals like this, square root of 2 times square root of 5, you can literally just multiply 2 times 5, and it does stay square root or radical. Here, you're multiplying square root of 7 times square root of 7, which actually just equals 7, but just in case you want to see some work, if you multiply 7 times 7, you get 49, and the square root of 49 is 7. Right here, as I'm starting to work through these, I could multiply this and get 6 times 12. I can get the square root of 72, but that really doesn't make sense, because you're always going to be asked to simplify. So instead of even multiplying 6 times 12 to get 72, I'm just going to break this down already. And remember, you can just multiply them, so putting everything under the same radical is perfectly okay. So there's the 6, and then the 12, I broke it down to 6 times 2, and now that there's 2 6's here, I can take one out, and the 2 has to stay there because it's not a perfect square. There's that one. I'm going to keep going here, guys. So here I can multiply square root of 3 times square root of 10, that's 30. And actually you could try to break down 30, but what you're going to find is all just 2, 3, and 5, so you can't even simplify that. Here, 10 times 35 is 350. Don't even bother with that. May as well just start breaking these down. 10 is 2 times 5. 35 is 5 times 7. So now, just by doing that, I'm just trying to do it the easiest way. You could make a factor tree like I did on a couple of them, but this is just as well. So there's 2 5's there. Take one out. 2 times 7, 14. Anything that stays under the radical, remember, you multiply it. Square root of 6 times square root of 2, that's square root of 12, but you may as well just break it down instead of multiplying. So 6 is 2 times 3, and then that 2, you're still multiplying by that. You got 2 2's, so bring one out. 3 stays under the radical. So when you're dividing radicals, you can, if possible, if it's divisible, you could just divide. Like here, 75 is divisible by 3. 75 divided by 3 is 25. It does stay radical, but the square root of 25 is 5, so simplify. Here, 90 divided by 2 is 45, so I have the square root of 45, which I'm going to break down to 5 times 9, and then the square root of 9 is 3, so 3 square roots of 5 is my answer there. Here, 48 divided by 6 is 8, so the square root of 8, but remember 8 is 2 times 4, and 4 is a perfect square, so the square root of 4 comes out. Whoops, that should be a 2, I don't know why I changed it, but either way, 2 radical 2 is what that answer is. Same skill set here, guys. 80 divided by 5 is 16, so square root of 16, which is just 4. Here, 48 divided by 12 is 4, so the square root of 4, which is 2. And then here, these are like, I'll just give you a quick little thought here on these. These are kind of like adding, like the first one, if you had 7x plus 5x, you get 12x. That's pretty much what this is. They're kind of like terms if they have the same radical. So 7 radical 2 plus 5 radical 2 is just 12 radical 2. 2 radical 5 minus 6 radical 5 is negative 4 radical 5. Here, they're all radical 7. 3 plus 9 minus 1, right? That's 1 radical 7. 3 plus 9 is 12. 12 minus 1 is 11. 11 radical 7. The square root of 2 plus the square root of 8. That you can't do that right off the bat, but you will be expected to simplify something like this. So this is 2 times 4, right? This is the skill from the first page. So now we're mixing the skills. We're simplifying and still possibly combining the like terms, if you will. So anyhow, 2 times 4, right? So bring down the square root of 2 here. Take the square root of 4 out. It's 2, right? And then you still have a 2 left inside. But now look what you have. 1 radical 2 plus 2 more radical 2's. 1 plus 2, 3. 3 radical 2's for that one. This one, all these are pretty much set up where you're going to end up with some like terms. So you're going to have to break these down. 50 is 2 times 25. Minus 6, 32 is 2 times 16. So there's different ways to break them down. I'm just trying to think of the way to break it down where I get perfect squares. So bring out the square root of 25, that's 5, right? And you will multiply that 5 by the 4. 5 times 4 is 20. Still have the radical 2. On this one, you're going to bring out the square root of 16, which is 4. And you would multiply that by the 6, so 4 times 6 is 24, and there is still 2 inside. So you see how these are kind of set up to where after you simplify them, you have like terms. 20 minus 24 is negative 4, right? So negative 4 square roots of 2 for that one. This one, the square root of 3 plus the square root of 12, and 12 can be broken down to 3 times 4, and the square root of 4 is 2. Let's bring that out. So I have 1 radical 3 plus 2 more radical 3s, so 3 radical 3 is my answer there. And so this next skill, you guys see what it says here, rationalize the denominator. Basically that means get rid of radicals in the denominator. So if there's radicals in the denominator, get rid of them. So, like, here's how you do it. You would just multiply by that very same radical. So here, square root of 6 on bottom. I want to get rid of the radical. Well, I just multiply by radical 6. And I will have to multiply top and bottom by radical 6 in order to make this fraction stay, equal to what it started out as. So on top, 15 times radical 6, 15 radical 6 on bottom. The whole point of doing this is to get rid of the radical, guys. Square root of 6 times square root of 6 is just going to give me 6. Remember, if you multiply it, you get square root of 36, and that's 6, right? So so when you multiply the two identical square roots, you just get the number as normal, not a root. And you still have to reduce just like a regular fraction, guys. 15 divided by 3 is 5. 6 divided by 3 is 2. So I have 5 square roots of 6 over 2. That's that one. This right here, I will advise you, is the exact same thing as this. It can be written either way. So in either case, I would multiply top and bottom. by the square root of 5 to get rid of the radical on bottom, right? To rationalize the denominator. So on top, 3 times 5, square root of 15. On bottom, square root of 5 times the square root of 5 is 5, right? The square root of 25 is 5. That you can't do anything with. And then here, 12 times the square root of 8. I'm just going to multiply it by the square root of 8. There's different ways you could do it, but one way to do it is here, right? So you get 12 times the square root of 8 on top. Square root of 8 times square root of 8 is 8. And so you're going to reduce this. You're going to divide by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. And then the 8, remember the 8 is 2 times 4, so you actually have to simplify that too. So the square root of 4 would come out, right? It would come out as a 2. And then you'd still have a 2 left inside, and I hope that you could follow all that. And I still have a 3 there. I'm going to have to multiply the 3 by that 2, and then I still have a 2 on bottom. Actually, I'm not going to multiply 3 times 2 because I'm just going to cancel those. So basically what you're seeing here is quite a few different ways to get to the end, you know, quite a few different paths to the answer. So everything that's left here is just 3 radical 2. Same skill set here, guys. We're going to get rid of the radicals on bottom. Remember, that's called rationalizing the denominator. You may have heard of that before. So all I do is multiply the denominator, you know, by the denominator. Same thing, whatever I do to the bottom, I do to the top. So I have on top 25 radical 10. On bottom, just a regular 10. Remember how that works. You can divide by 5 here. 10 divided by 5 is 2. 25 divided by 5 is 5. And so I have 5 radical 10 divided by 2, over 2. Can't do anything else with that. Here, I'm going to multiply top and bottom by the square root of 7. So on top, I'm going to get the square root of 14. And on bottom, I'm just going to get a 7. Nothing else to do with that one. Here, this next one, I'm going to multiply top and bottom by the square root of 18. And so on top, I'll get 5 square roots of 18. On bottom, I'll just get 18, and I do have to simplify this a little more. Right? The square root of 18 is 2 times 9, or I mean 18 is 2 times 9, so then I can take the square root of 9 out. It's 3, and the 3 will get multiplied by that 5, and I still have 18 on bottom, so I'm going to keep going here, guys. You know, I do just want to be as efficient as possible. So basically, instead of even multiplying 3 times 5, I can just divide by 3 on top and bottom, because 18 is here. I can divide that by 3, and then I have that 3 I pulled out of the radical. So I'm going to skip a step here and say I'm going to divide by 3. So 3 divided by 3 is 1, and 18 divided by 3 is 6. So I'm kind of reducing before I even multiplied. And I still have a 5 and a square root of 2. And I have a 6 now. 5 square roots of 2 over 6. And moving right along, these next ones, they're a little different. Look at the index, right? A square root, guys, a square root is basically saying, right, like say I have the square root of 25. And it's basically saying what number do you have to multiply twice to get this number. So the square root doesn't put the little index in there, but that little index is implied. So basically this is the same as this, because it's saying what number do you have to multiply twice to get 25, and it's 5. So these are basically saying what number do you have to multiply 4 times to get that number, or 3 times. This one is basically would have a 2. So I'm going to move along. So I am going to make factor trees for these. I don't know a better way than factor trees. So 48 is 4 times 12, 4 is 2 times 2, 12 is 3 times 4, and break down that 4 for 2 times 2. Remember, since the index here is a 4, it's a 4th root. That means I actually would have to have 4 of the same factor to pull one of those out from the radical. So look, I have 1, 2, 3, I have 4 2's. That means I can actually pull a 2 out. Again, the reason I need 4 is because it's a 4th root, not a square root. And notice there is still a 3 here, so that will go back under the root, and if I forget to put the 4, technically it's wrong. So, let me just put that there. So, I was wrapping that one up. This one, I'm going to, same thing, I'm going to break this down, 25 times 10 It's 250, 25 is 5 times.